Hello everybody, George Taylor from Entracte Audio here. Once again talking about damping factor. If you saw the last video, we talked about the general characteristics of damping factor, what it is, what it does, how it was measured. Basically speaking, damping factor tells you the ability of a power amplifier to control the movement of a woofer. Solid state amplifiers have higher damping factors than tube amplifiers. Solid state amplifiers have a damping factor of 80 or above these days. Tube amplifiers have a damping factor of between 2 and 20. And the damping factor is determined by taking the speaker impedance, which we assume to be 8 ohms. And generally speaking, that's not accurate, but it's close enough to give you an idea. And we divide that by the output impedance of the amplifier. So 8 ohms over whatever the value of the output impedance of the amplifier gives you a damping factor. Okay. In a lot of solid state amplifiers, the output impedance is 0.1 ohms, so that would give you a damping factor of 80. Anyhow, we said in the last video that damping factor will affect the sound of a system and affect the sound of speakers, and it does do that. And we're not going to illustrate that because it's not really possible for you to hear what we're doing, but we have constructed a damping factor adjuster, which has been called the dumping factory or the dumpy farter. It's got a number of names now. If you can come up with a better one for it, by all means, email us. We love to be amused by that kind of thing. So what we have here, if I can get the magic wand, is we have a series of controls. So we have a control, a damping factor control for the positive side of the right channel, positive side of the left channel, negative side of the right channel, negative side of the left channel. Okay. So we can adjust damping factor on both sides of the signal. This particular box is connected to the speaker output down here of the power amplifier, comes into the box, goes through the control set, comes out here at speaker terminals, and runs to the speakers. Okay. Now, the way this works, it's set up as minimum and maximum. Maximum means maximum damping factor. So when the controls are set all the way to maximum, what we basically have is an unadjusted current path running from the power amplifier all the way to the speaker. So whatever the damping factor of the amplifier is, when you set it on maximum, it's still the damping factor that the speakers see. Right? Now when we start adjusting these, the more we turn these knobs counterclockwise, the lower the damping factor, which is why the control over here says minimum. So if we adjust all the way here, what we've got now is we have a damping factor of 0.5, which is a very, very, very low damping factor. Okay? And the cool thing about this is that you can, there's a floating adjustment. You can set different levels of damping factor and see how it affects amplifiers and speaker combinations. You can decide that you're just going to work with the negative side, so set the positive sides and see how that works. Depending on the amplifier, this may not work so well because there are some amplifiers that just send a signal out through the positive terminal of the speaker, so therefore the speaker sees the signal before it comes back through the negative side. So the more effective way to do it, if you wanted to see what one side would do, would be to eliminate any damping factor on the negative side of the signal and just work with the positive side. Now it's interesting because I've done some experimenting with this. I'll more about that in a minute, and it does make a difference which side of the signal which whether you adjust the signal on the positive side or the negative side. So, moving onwards. So this is a prototype unit. This is probably not a production unit, but this is an interesting thing we're using to find out how speakers react to changing damping factor, how amplifier and speaker combinations work. Because not every speaker really wants to see a very, very high damping factor. Different situations, different systems, it depends. This little guy is called the DF1. And what you do with this is you attach this. We can try and look at this over here, right? I can actually do it. I'll be careful. What you do with this is you would take one speaker terminal out, and you would plug that into the back of this. You can also do this at the amplifier end if you wish. And then you plug it into your speaker. Now what you've done is you've installed a damping load on the positive side of the positive signal of the speaker input, and the damping factor that this speaker sees is now 1. All right. If you wanted to put a second one on here, you could put one on this side, and you could lower the damping factor to 0.5. All right. Now, obviously, you would do it. Whatever you do to one speaker, you should probably do to the other, because it's going to sound awfully funny if you've got one speaker running at a damping factor of 1 and one speaker running at a damping factor of 40 or 60 or 80 or something like that. So these are handy little devices. And the cool thing, I'm not going to talk too much about brands of speakers or anything like that, but I have obviously I'm an audio shop, so I have a selection of speakers here. And I did find a couple of speakers that worked really, really well with one of these on the positive terminal. It created the cleaner sound stage. It created and it really, what I found is that it really seemed to help develop a nice sound for somebody that wanted to listen to speakers at a low volume. It also seemed to take a little bit of the edge off of the treble, but it didn't really seem to take away any of the detail or any of the. It didn't seem to decrease the level of frequency output, and it just sweetened things up a little bit. So I guess I'm not sure how to describe this yet. I don't want to go off and say that using these can simulate a tube sound. I can say, and of course, none of these things you would use if you were using a tube amplifier. If you've got a tube amplifier, then you've already got a low damping factor, and this is, again, we're not adjusting damping factors upwards, we're adjusting damping factors downwards, in this particular experiment anyway. So this is to maybe simulate a tube sound. I don't want to go that far, and I'm not even sure that I could at this point say, because this is new, this is research that's about 2 weeks old, and I wouldn't even call it research yet. I would call it an idea that we're working on. I'm not even sure that I could say specifically who this would be good for yet. But we do know in the 2 weeks we've been working on this that there are speakers that react positively to it. So it might be something you want to look into or try down the road. Anyway, as always, if you have any questions about any of this, please visit me at www.entracteaudio.com. Email me at entracteaudio@rogers.com. You can also find out more information at www.angela-gilbert.com. And there's also a provision on this website if you want to email questions. You are more than welcome to do so. If you've got feedback, we'd love to hear it. If you've got a new name for the damping factory adjuster, go for it. Love to hear that as well. And as always, thank you for watching. Hope you enjoyed the video.